Hello again. This video we start with another example of the Hungarian algorithm. So remember that this is used to allocate tasks to people or to things in order to minimize cost or time. So in this one we've got 4 different people, Jessica, Simon, Emma and Peter, who can perform 4 different tasks, which are just called W, X, Y and Z, but they take different amounts of time to complete the tasks. So we've got a matrix below that represents the times in minutes that each person takes to complete the task. And our job is to use the Hungarian algorithm to allocate the tasks so the overall completion time is a minimum. And then it says how much time will be required to complete the project. Okay, so what we're going to do is kind of go through our same steps as in the previous video. So hopefully you've already watched the previous video and seen one example of the Hungarian algorithm. So essentially, and I've written the first couple of steps out in advance to save a little bit of time, but the first step is that we do row reduction. And that's where we find the smallest number in each row and subtract that number from everything in the row. So for example, in the first row, the smallest number is 17. And so we're going to subtract 17 from all these numbers. In the second row, the smallest number is 18. And so we're going to be subtracting 18 from all of those numbers in the second row. In the third row, the smallest number is 14. And so we subtract 14 from every number in that row. And in the fourth row, the smallest number is 11. So we'll be subtracting 11 from every number in that row. Now, if you want to, and I should have said at the start, if you want to pause the video and actually have a go at the example yourself, that's a great idea. And then you can just push play and sort of watch through to see what I've done. So first step, I'm trying to gradually reveal this. You can just see at the bottom there. So once we've done this row reduction, you can see that the new numbers that we've ended up with. So for example, in the first row, when we subtract 17 from each of these numbers, we're left with 17 take away 7 gives 0, 24 take away 17 gives 7, 42 take away 17 gives 25, and 21 take away 17 gives 4. Right. For the second row, we've taken away 18 from each number. So 25 take away 18 gives 7. 18 take away 18 gives 0, 19 take away 18 gives 1, and 20 take away 18 gives 2. And we've done the same thing for the third row and the fourth row. We've subtracted 14 and 11 respectively from each of those numbers. Then remember that the next step, once you've done row reduction, is to do column reduction. So you find the smallest number in each column and subtract that from all other numbers in the column. So for example, the first, well actually in this case, the first two columns have got zeros in them. And so when we subtract, the smallest number from everything in the column, or nothing changes, because 0 take away 0 will still be 0, 7 take away 0 will still be 7, 15 take away 0 will still be 15. But in the third column, the smallest number is a 1, and in the fourth column, the smallest number is a 2. So those third and fourth columns will actually change after we do the column reduction. So you can see in this next step that the first two columns actually haven't changed at all. But the third column, we've subtracted 1 from every number to get 24, 0, 16, and 5. And the fourth column, we've subtracted 2 from every number to get 2, 0, 6, and 1. Okay, so let's pick it up from here. So the next step is then to do the crossing out step, which is where we try to cross out all the zeros using as few lines as possible. So I've got 3 zeros in a line there. I'm going to cross those out first. Then I've got 2 zeros in this first column I can wipe out. And now I've just got 1 left. And so it doesn't matter if you go down or across. Just for the sake of it, I'm going to go across. You'll get the same answer either way, but there we go. And so that required 3 lines. 3 lines required. And because there's 4 tasks, well, we actually have to keep going, because remember that we stop if the number of lines is equal to the number of tasks. So now we get to this step where we say, okay, well, our next job is we find the smallest uncovered value, which in this case is a 1, and we subtract that number from every uncovered number in the matrix. So we're now going down to rewriting this matrix and start with the uncovered numbers and just take away 1 from them. So this 7 becomes a 6, 24 becomes 23, 2 becomes 1, 9 take away 1 becomes 8, 5 take away 1 becomes 4, and 1 take away 1 becomes 0. Then, this was the other sort of trick to this step, the intersections, so all the numbers at the intersections, we actually add that 1 to them. So 7 becomes 8, and 15 becomes 16. So we have to add this number to all values at the intersections of the lines. Everything else, so all these other covered numbers, just stay exactly as they are. So you just copy them down. 0, we had 0, 0, 0, we had 0, 16, 6. And we had 0 at the bottom there. All right, and now we try the crossing out again. And we try to cross out, zeros in as few lines as we possibly can. Again, I can kind of cross out 3 in one go here. I can wipe out 2 zeros, in one line going either across there or down there. So I go across. And now you can sort of see that whichever way we've done this, we're still sort of left with 2 different zeros that can't be crossed out in one line. And so that means no matter which way I go, across or down, I'm kind of getting 4 lines required here, which is great, because that means we're finished. So the minimum required lines to cross those out was 4, which means we're done, we've finished. What we then do is actually make our allocation. So what's useful to do is go back to the original matrix or table or however the information was given and just label the rows and columns again. So I'm just going to put, J for Jessica, S for Simon, E for Emma, and P for Peter. And then the jobs were W, X, Y, and Z. And remember that the zeros kind of tell us how to do our allocation. So what you might do is you go through and say, well, for Jessica, she can do, this is just saying she can do job W only. That's the only one we should give her. She doesn't have sort of choices of other ones. So let's just lock that one in. For who's S, Simon, we can give either job X, Y, or Z. All right, so he's got some options there. Let's leave him until last. Emma can do just job X according to these zeros. So let's give her job X. Okay, and Peter, well, he's got options of job W or job Z. Now, in this case, well, we can't give him W because we've already given that to Jessica. So let's give him job Z. And that then helps us decide what Simon should do, because Simon, even though he's got 3 possible jobs here, 2 of those jobs have already been allocated, right? We're not going to give him job X. We're not going to give him job Z. The other one left that he should do is job Y. Okay. And so these zeros, you can see we've got 1 0 in each row and 1 in each column, which means each person's being given one job, and each task is actually going to get done. So the question was, how should we allocate the tasks? So Jess should do job W. Simon's going to do job Y. Emma will do job X, and Peter will do job Z. Right, but this question did also say, we go back to it, how much time will be required to complete the project? So let's go back to what we said, which was Jess doing job, it's hard to show you both of these things, isn't it? Jess doing job X, Simon Y, and so on. And if we kind of pick those out from the table, it doesn't help that I've already made a mess of this, but anyway, Jess is going to do job W, so that's Jess there. Simon's going to do job Y. I'm trying to use a different color, although pink and red don't show up that different, do they? Emma's going to do job X, and Peter's going to do job Z. Right, so running through those, Jess doing job W is going to cost, or not cost, take 17, was it minutes or? Yep, in minutes. So it's going to take 17 minutes. Simon to do job Y is going to take 19 minutes. I should have put minutes there. Emma to do job X is going to take 14 minutes. And Peter to do job Z is going to take 14 minutes as well. All right, so the total amount of time it's going to take, or the overall, I suppose, amount of time, if we add all these together, well, 17 minutes plus 19 minutes, what's that, 36 minutes, then plus 14 is 50, 64 minutes in total. All right. Now, you don't use a calculator much in the networks topic, but if you ever want to just double check things like that on your calculator, do that, or even at these earlier steps when you had to take away 17 from every number, don't forget you've got your calculator there, even though we don't use it a lot in networks, you can still use it to make sure of all your number crunching. Okay, so that's how we kind of answer another Hungarian algorithm question. So it's a pretty tricky process, but you keep going back to your steps and following them carefully, and once you sort of practice it a few times, it is a bit like riding a bike, it'll stick. Okay, last example in this section, I know it's a bit of a long one. This one comes back to actually a bipartite graph. You can see straight away, without even reading the question, you've got a picture of a bipartite graph here. So this one says George, Harriet, Ian, Josie, and Keith are a group of 5 musicians, and they're forming a band where each musician will fill one position only. And this graph sort of demonstrates what position they're each able to do. So for example, George could play the drums or could play the guitar, right? So he obviously knows how to play the drums and guitar, but not keyboards, saxophone, or vocals. Our job is to determine who should fill each position in the band. So this actually doesn't require the Hungarian algorithm. This is like it's already jumped to the last step. We can see who can do what. We just have to allocate it properly so that each person will get one job. So my tip with these sorts of questions is to start with like anything that has to be locked in. Like if there's one person who can only do one thing, allocate that straight away. Or if there's one position that can only be done by one person, lock that in straight away. So for example, I can see that the only person who's able to play saxophone, we look here, only person who's able to play saxophone is Ian. So the only choice we have is to kind of give Ian that job there. We're going to lock that in. All right, so Ian is going to do the saxophone. That's done, that's allocated. Okay, so Ian has to do the saxophone. Okay, let's look carefully now. Is there something else we can say, we can do that now just kind of has to be locked in? Well, this one's quite tricky, but if I look carefully at I'm going to run out of colors, so I'll just keep using the same one. Look carefully at the keyboards position, right? The keyboards position, well, there were 2 people who could play keyboards, Ian or Keith, except Ian's already allocated. So Ian, obviously, because he's playing the saxophone, he can't play the keyboards. So now our only choice, the only person who's left who could play the keyboards is Keith. All right, so let's kind of lock that one in. Keith got to play the keyboards. So those two musicians are done, and the two positions are done as well. And we can kind of just keep making our way through using like almost this process of elimination. So looking at the vocals position now, the vocals position could be filled by either Keith or Josie, because they're the only two arrows that lead to that position. But again, Keith is already allocated, so we can't give Keith the vocals, which means Josie is going to be on vocals. So we have to do that. We have to give Josie the vocals. Oops. So Josie's going to be on vocals. Our last two musicians and positions are George, drums, and Harriet, guitar. So we've got to figure out, who should play which. So let's see. Well, guitar, if we look at that one, really out of George and Harriet, only George can play the guitar. Harriet doesn't have an arrow to guitar there, so George has to play the guitar. That's locked in. Which means Harriet's left with the drums, right? And that's all kind of worked out because we've got an arrow going from Harriet to drums, so we know that she can do it. So I should have grabbed a highlighter actually to make that a bit clearer, but you can kind of see now that we've allocated all the positions, and we've just got to read the arrows that I've gone over there. This would have been much better with a proper highlighter, but anyway. So what did we say? We said George is going to do the guitar. So George, guitar. I should have written them down as I went. That would have been better. Anyway, Harriet, we gave drums. Ian was saxophone. Josie was vocals. And Keith, good old Keith, Keith's going to play the keyboards. Okay, so that one's an example of an allocation question. It was a little bit different because we just had to do it straight from a bipartite graph, but that's a super common exam question. In fact, that question has just been copied from a past exam. So a lot to get your head around here. I hope it's making sense, but as always, if it's not, get in touch with your maths teacher and they'll be able to help you out. Bye, everybody.